Hello everyone and welcome back to FE Exam Prep Solutions. Today we're going to be tackling the mechanics and materials problems. So break out your calculator, your FE reference manual, pen and paper, and we're going to go through this one. So let's jump into the problem. Right here we have question: a steel rod has a diameter of 0.75 inches and carries an axial tensile load of 12,000 pounds. What is the normal stress in the rod? And we have four answers, I should say, down below. How do we go about solving this? Well, what are we looking for? What is the normal stress? Okay, I don't have the symbol for stress here, but I'm going to say normal stress. Where should we go first? Always FE reference manual. Let's see what we have for, if we look up the term stress, we're going to get a lot of answers, but we're going to want to find it in the mechanics of materials section. Total normal stress. Excellent. What does that equal? The normal force over the cross-sectional area. So we're going to be looking at P over A. Okay. You can generally just remember stress equals P over A is a good equation to have memorized and to, have in the back of your head, but it's also in the FE reference manual there. What section is it on? It is on section, I believe, civil engineering, geotechnical. And as we go down, you can find it there. So we're looking at P over A. Well, what is the load? 12,000 pounds. And then what is the area of the rod? Well, we have a diameter. So we know that the diameter is going to be pi d squared over 4 is going to be the area given a diameter. You could divide it by 2, do pi r squared if you want to do that with the area, but pi d squared over 4 is a much quicker way to do it, given that you're given diameters a lot. You're not nearly as commonly given radiuses on the FE exam. A lot of the times it's diameters. So also note the units. KSI, not feet, but it's in inches. So we can leave that diameter in the 0.75 inches. So pi times d, let's do squared. All of this is going to be over 4, right? 0.4418. So we're going to have 12,000 divided by 0.4418. That gives us an answer of 27,161, so 27.2 KSI. So the solution here is going to be C, 27.2 KSI. Again, the FE exam, not exactly always testing depth, but how you approach the problem, your accurateness with the units, and how to best apply the principles. Total normal stress is the equation we found, and we plugged that in there carefully with the units, and we got the right solution. So if you have any questions, leave it down below. I've got my free guides in the description. If you're looking for direct help with your FE exam prep, looking to pass in 90 days, you can contact me directly down below as well. Thanks so much for watching. Anyways, I'll see you guys in the next video.